Hi, this is Bear Givens, and in this video, I want to talk a little bit about how to intuitively visualize some of the product spaces that we study in topology classes. So this video is going to be more about how to take two spaces and then take their cross product and come up with different ways to picture them. Okay, so for the first one, I'm going to look at I cross R. So I is the unit interval from 0 to 1. I is the unit interval from 0 to 1. And R is the usual real number line. So remember that I cross R sort of formally and as like a set theoretic definition, it looks like ordered pairs of the form x comma y, such that x is a real number between 0 and 1, and y is any real number. Okay, so that's saying x is an element of capital I, y is an element of the reals. So it's ordered pairs that look like the first coordinate has to be between 0 and 1, and the second coordinate has to be in the reals. So you just want to think of a way to draw like a diagram where each point in the diagram could have a unique representation in terms of these two coordinates. All right. So I think one way to do this is to think about doing I, which is 0, 1. There's my I. And then just imagine that kind of going up and down a whole real number line. So this is my reals, and this is my I down there. And then if you think about any point that I might want to look at here, if I take a point right here, x comma y, I could think, okay, so the x coordinate comes from somewhere in the interval. Sorry, the first coordinate comes from somewhere in the interval. And then the second coordinate is a real number. Okay. So you can think of I cross R as being this sort of infinitely long strip of paper, right, of width 1. All right. Then the next one I want to think about is I cross S1. I cross S1. So again, I here is the unit interval from 0 to 1. And S1 is the name that we use in topology for the unit circle. So here again, I want to think about a way to visualize. I want to think about a way to visualize I cross S1 would be points of the form x comma y, where x is on my unit interval and y is on my circle. So I want to have a way to visualize how I could kind of make some sort of grid or something where the location on the grid would tell me, what would the first coordinate would be somewhere between 0 and 1, and the second coordinate would be somewhere, a location on a circle. Okay. So one way to do that is I could sort of imagine taking my eye, maybe like this, and then imagine taking this eye and kind of spinning it around the circle. So taking the eye and kind of putting like a copy of it in all directions around my circle. So a way of thinking about that would be to sort of think about I cross S as being like this annulus. It's my little pineapple ring here. Something like that. Okay. And so I'd have kind of like maybe the sort of starting eye. So let me say, okay, for example, on the circle, I'm going to sort of think of this as being my starting point. This is where the angle, if this were drawn on an XY plane, the angle would be 0. That's like theta equals 0. And then on my unit circle, 0 is right there. Sorry, not unit circle, unit interval. And that would correspond to this point right here. But now if I want to take another point, let's say I want to take a point where I have maybe on my unit interval, I'm at like 0.75. And on my unit circle, maybe I'm down here in this lower quadrant, in the third quadrant of the unit circle. So where would that fall on this kind of diagram? Well, I'm going to come around on the unit circle. I'm going to come around down to this quadrant down here somewhere. And then on my unit interval, zero's like on the inside and one's at the outside. And so I want to get this point that's sort of like 3/4 of the way across. So that point might be somewhere like there. Okay. And so you can kind of see how you could take combinations of a point from the unit interval and the point from the unit circle, and then you could draw them on this grid diagram, this annulus or this pineapple ring that I've made by using the first coordinate as sort of like how far you are from like the inner ring to the outer ring. And then the point on the circle is like where on the whole circle are you? Um, One way to think about this is that I sort of took the unit interval. I started with the eye, and then I kind of like moved it around. I made copies of it, sort of following around a circle. I could go the other way. I could start with my circle. So I can start with my circle. And for the purposes of drawing, I'm going to draw it as if it's lying in a flat plane. So I'm going to draw it kind of with some perspective to kind of look like that. And then I could imagine taking copies of that circle along the unit interval. So I can imagine taking the unit interval here right next to it and then making copies of this circle coming up the unit interval. I'll draw the interval on both sides. So I can imagine it like this. To make it a little easier to picture, I'm going to make the bottom edge a dotted line. Okay, so I can imagine something like that. So I'm taking copies of the circle and I'm getting one copy for each point on my unit interval I. And if I think of the point on the unit circle that corresponds to 0, and then on the unit interval also corresponding to 0, that would be this point down here. And if I think of the other point on the unit interval as being at about 0.75, this point here, and then down here in quadrant 3, that would look like, let's see, about 0.75 up the way of the eye. So that's going up the cylinder. That would be maybe right around here. Okay. So I can either think of I cross S as this annulus, or I could think of it as a cylinder, as the surface of a cylinder that doesn't have any top or bottom. Okay. So it's two different ways that I could picture this. And then you might say, well, which one is the right way? Well, technically, neither one is the right way. Technically, formally, the definition of this is that it is this collection of ordered pairs. And so whatever way that we can picture it is going to be useful for us to make sure that we can imagine it, as long as however we picture it has a way where given any combination of something from I and something from S1, there is exactly one unique point on this, however I'm picturing it, like as long as you have a way to sort of go back and forth between the ordered pairs and the surface, a one-to-one correspondence, then however you can picture it is the right way to picture it if it helps you see better what is happening. All right, so that is two examples in this video of visualizing product spaces. Thank you for listening.